Hello friends. So today we'll be discussing about some of the geographical concepts which were there in news very recently. Among them, one of the topic what I have taken for discussion, today's discussion, is something called as ENSO neutrality. Now we have to understand what is this ENSO, right? And what exactly I mean by this ENSO neutrality. We'd have heard about something called as La Nina. We'd have heard about something called as El Nino. Exactly in between, I have a third condition, we call them as what? ENSO neutrality, right? We'll try to understand what is this ENSO first, then what is this ENSO neutrality, then very importantly, what exactly is the impact that ENSO in general will be having in Indian monsoon, and how exactly this ENSO neutral condition is going to impact this Indian monsoon. In that case, my dear friends, when I just talk about ENSO, what exactly ENSO, right, means? What is the acronym for this ENSO? ENSO means El Nino and Southern Oscillation. The anomaly or the temperature difference that happens in the tropical waters of Pacific Ocean, generally we call them as what? ENSO. Sometimes what happens, when I just talk about this Pacific Ocean, right? Either side of the Pacific Ocean, I may not have the same temperature. For example, if I just take the tropical waters of Pacific Ocean, most of the time I'll be finding the difference in temperature. Sometimes the eastern section will be warmer, western section will be colder. Sometimes I'll be having the reversal of the same. This oscillation is what we call them as what? We call them as what? ENSO, right? To be very precise, we call them as what? El Nino and Southern Oscillation. And this oscillation particularly happens in the southern hemispheric part of Pacific Ocean. That's the reason you call them as what? Southern Oscillation. So it is all about the variation in the temperature between the different, say for example, margins of the same Pacific Ocean and tropical waters. We call it as ENSO, right? Now when I just talk about this ENSO, my dear friends, right? What are the different, say for example, when it comes to the distribution of temperature, how exactly normally we have, right? Say somewhere, I'm taking the condition of normal condition. What is this normal condition? Most of the time, if I'm there in Pacific Ocean, not only in Pacific Ocean, any ocean in general, if I just take it, generally I find the western section of the water will be generally warmer than the eastern section. That's the reason very popularly we say, in general, right, any oceans you take, west is warm, right? If you ask me why exactly the western section of the ocean is generally warmer, because I understand any ocean you take it, ordinarily, we do have an exception, right? But ordinarily, my dear friends, the western section of the ocean will come under the influence of warm currents. Whereas the eastern section of the ocean will be coming under the influence of what? Cold current. So that's the reason we say west is warm. Okay. Now here, when I just talk about any ocean, particularly when I talk about Pacific Ocean, western side, I have this Australian coast. Australian coast coming under the influence of a warm current called as East Australian current. With respect to Australia, that is east. With respect to Pacific Ocean, that is west. Correct? Right. Whereas, when I just talk about the South American coastline, particularly when I talk about the Peruvian coastline and Chilean coastline, they come under the influence of a cold current called as Peru current, or sometimes you call them as what? Humboldt current. Okay, whatever it is the case. This is what most of the time I'll be experiencing in Pacific Ocean. We call them as normal condition. Sometimes this normal condition is also called as ENSO neutrality. But see, there are various analysis and even the net sources says that technically there is a difference between normal condition and ENSO neutrality, but still impact on the climatic pattern will be more or less similar, right? Now, if this is the normal condition, and if you ask me what exactly is the reversed condition, this reversed condition is what we call them as what? El Nino condition. Completely things will change. So during El Nino, what happens? South American coastline, which is generally cold, becomes warm. Australian coast, which is generally warm, becomes comparatively cold. This reversed condition of Pacific Ocean, tropical waters of South Pacific Ocean, is what we call them as what? El Nino. We call it as El Nino. And if you ask me why exactly this changes is happening, it is very simple. When I just talk about why exactly this warm water is actually moving towards Peruvian coast, if you ask me, We have a reason and explanation for the same, because I understand across the Pacific Ocean, one side I have Australian coast, another side I have Peruvian coast. Australian side I have warm waters. Warm waters will be less in density, slightly it will rise. Peruvian side I'll be having cold waters, more in density, slightly it will be sinking, slightly. See, when I say the rise and sinking or subsidence of the water, I'm super exaggerating it, correct? But still, there is a gradient difference, right? Few centimeters of gradient difference across Pacific Ocean. So what happens always, I understand, from the elevated sections, the warm waters from Australian side will start moving towards what? The Peruvian coast. That's what? The moment you're seeing it. Once the water reaches the Peruvian coast, once this warm water replaces or superimposes the cold Peruvian current, there comes the condition of what? El Nino. Okay, right. Now what is El Nino? I have said. Reversed condition. Normally, ordinarily speaking, South American coastline will experience cold condition. Australian coast will experience warm condition. That is normal condition. If it is going for a reversal condition, then that reversed condition we call them as what? El Nino. Then comes one more question. Okay, fine, El Nino. What is El Nino? I had somewhere I understood. Okay, reversed condition of Pacific Ocean. Peruvian current being replaced by warm waters. You call it as El Nino. Then what is this La Nina? My dear friends, as I said, ENSO itself stands for El Nino and Southern Oscillation, right? It means this warm and cold water will be going for what? Oscillation, right? So one side, Australian coast will be more warmer. Some part of the time, the Peruvian waters will become what? More warmer, whatever it is the case, correct? Now what happens? Again, after reaching the warm waters, reaching the Peruvian coast, this warm water will again start moving towards what? Australian coast. It will start oscillating it, okay? So once the warm water starts leaving this South American coastline, once this cold Peruvian current gets re-established back in the surface of the ocean, that condition we call them as what? La Nina. Okay, so what is El Nino? I know, right? Cold Peruvian current being superimposed by warm waters, or cold Peruvian current almost goes missing in the surface, I call them as what? El Nino. The cold currents once again getting resurfaced in the surface, right? The re-establishment of cold ocean currents, we call them as what? La Nina. Now comes one question, okay, that is fine. But if that is the case, what exactly is the small difference I have between this La Nina condition and normal condition? Okay. La Nina condition and normal condition, technically speaking, more or less, it looks similar. But one thing is there. When I talk about La Nina condition, I'll be having the South American coast experiencing more cold condition than the normal condition, right? It means the temperature of this water will be very, very less comparing to what? The normal temperature of this ocean. Whereas when I talk about normal condition, I may not have that much of cold temperature, right? That is what the only difference or the major difference what you experience. I repeat again, La Nina condition, the cold condition along the South American coastline will be very intense. Normal condition, that much intensity of this cold condition, I will not have it. Okay. Now, that's a small difference what I have between this La Nina and the normal condition. See, some of the text even, right, we used to call, just for simple understanding, we used to call that La Nina condition is the normal condition of Pacific Ocean. Okay. But somewhere I understand, right? La Nina is all about intensified, right? Slightly the temperature anomaly. Okay. What I'm just trying to say, even in class, sometimes we used to say that El Nino is a reversed condition of Pacific Ocean and La Nina is a normal condition of Pacific Ocean. But still, technically speaking, normal condition and La Nina, there is a difference. What exactly is the difference? I told you. Now to consolidate this fact, my dear friends, whenever I just talk about this oscillation we have three phases. When I talk about El Nino, I said El Nino is completely a reversed condition where American coastline, South American coastline will experience warm condition, Pacific Ocean experiencing, Australian coast experiencing cold condition. La Nina is exactly reversal of El Nino. And exactly in between, we have a condition called as what? Neutral condition. So what is this neutral condition? Somewhere I understand the temperature anomaly, the temperature differences, right, will not be so great when it comes to the normal temperature pattern of this Pacific Ocean. Okay. Now I have to answer one question. If I understand that what is this La Nina and El Nino, including this neutral condition, how exactly it is going to affect Indian monsoon? Now, my dear friends, I assume that you know the mechanism of this Indian monsoon. In simplicity, we said Indian monsoon or the so-called southwest monsoon is nothing but a deflected southeastern trade in northern hemisphere. Right? For example, by default, the southwest monsoon is what I am calling it as Indian monsoon. If you ask me what is the reason, I'll tell you very simple. I know the fact that when I talk about Indian monsoon, we have two monsoons. One, you call them as what? Southwest. Number two, you call them as what? Northeastern monsoon. Correct. Now, why southwest monsoon? By default, I am taking it as Indian monsoon for the simple reason. This is one single largest wind which is covering 90% of land area. Barring few regions in India, 90% of the land is being covered by the single largest wind called the southwest monsoon. Number two, it brings nearly 75% of annual precipitation. Nearly 3/4 of the precipitation what we experience every year is brought by one single wind called the southwest monsoon. That's the reason whenever I say Indian monsoon, by default, I am taking what? Southwest monsoon. Unless and until examiner specifically says that he's talking about northeastern monsoon. Okay, fine. As I said, somewhere I believe, somewhere I take it into consideration that you know what is southwest monsoon, right? What exactly is southwest monsoon as a mechanism? See, somewhere if I just take the concept of this ITCZ, if I talk about the concept of ITCZ, I know the fact this is the time when this ITCZ or intertropical convergence zone, you call it as equatorial low, whatever it is the case, it will be completely placed in northern hemisphere. One exceptional bend will be recorded over this Indian subcontinent, right? Given the vast continental size of Asia, right? Now, somewhere I know that the two winds will be merging with ITCZ. One is the northeastern trade that is coming from northern hemisphere and the southeastern trade that is coming from southern hemisphere. But what happens? The southeastern trade that is coming from southern hemisphere has to enter northern hemisphere because ITCZ is completely confined to northern hemisphere. So what happens? As and when the southeastern trade enters northern hemisphere, due to Coriolis deflection, this wind will start deflecting towards what? Right in northern hemisphere. See, right at equator, Coriolis force is absent. That is okay. Once it surpasses this equatorial region, this wind will start getting deflected towards right, and this wind will be flowing as southwest monsoon over India. So that's the reason we say in simplicity, southwest monsoon is nothing but deflected southeastern trade of southern hemisphere. Okay. Now, coming to the impact of this El Nino or La Nina or in general ENSO with Indian monsoon, I'll tell you. I told you, the southeastern trade of southern hemisphere, when it gets deflected in northern hemisphere, I call them as what? Southwest monsoon. So one thing I understand, to have a successful southwest monsoon, the southeastern trade of Indian Ocean should be strong. Now comes one question. What is this question? Right? The wind that is coming to India, is it only coming from Australia? If you ask me, answer is no. It has an indirect extension till where? Till the Peruvian coast. Till where? Peruvian coast. Okay. How it is going to affect, I'll tell you, my dear friend. See, I understand. To have the successful Indian monsoon, I know that a low pressure should be there over Indian landmass. Okay. Relatively a high pressure should be there in Australian landmass. Only then I'll be having this successful southeastern trade. Correct? Right. Now, okay, even when I just talk about the seasons, it is somewhere matching. Okay. I'll be having the southwest monsoon, particularly in the month of June to September. Largely it is summers of northern hemisphere. Having low pressure created over land during summer is very much okay. During the same season or during the same period, I'll be having winters in southern hemisphere. Having the high pressure getting developed over Australia is also very, very common. That is okay. Now here, I have one more thing. For the successful Indian monsoon, two things has to be very strong, right? Certainty should be very high. Southeastern trade of Indian Ocean should be high. And my dear friends, southeastern trade of Pacific Ocean should also be what? Certain. Only then all that wind which is supposed to come to India will be coming. Here, forget about, say for example, this southeastern trade of Pacific Ocean. Sorry. Forget about the southeastern trade of Indian Ocean. I'll just come to the southeastern trade of Pacific Ocean, my dear friends. Talk about the southeastern trade of Pacific Ocean. When exactly the southeastern trade will be very strong? Logic says Australian side should have a low pressure, comparatively. Low pressure and high pressure is a comparative term. Don't go for absolute terms. Okay. In comparison to the Australian coast, the Peruvian coast should have what? High pressure. So normally what happens? Peruvian coast will come under the influence of a cold current called as Peruvian current. And this cold current will be resulting in creating high pressure. And Australian coast comes under the influence of a warm current called as East Australian current, which is a warm current, correct? And this warm current will make this place as a low pressure. So generally what happens, right? If we have this low pressure and high pressure created across this Pacific Ocean, what happens, my dear friends? Assume that I have a high pressure here and you have a low pressure here. So very easily, this wind will be having its flow across this Pacific Ocean. Okay. Under a normal condition, right, Indian monsoon to be successful, southeastern trade will also be certain, southeastern trade of Pacific Ocean will also be certain, southeastern trade of Indian Ocean will also be what? Certain. But what happens? Whenever the southeastern trade of either Pacific Ocean or Indian Ocean, if it is getting affected, it will in turn affect what? Indian monsoon. Now my dear friends, El Nino will be affecting it. Okay. Now what happens? El Nino, when I just talk about El Nino, my dear friends, the southeastern trade becomes very weak. Somewhere if I'm just going to it, somewhere, right? When I just talk about El Nino conditions. When I talk about El Nino conditions, right? Almost I'll be having a wind or I'll be having what? A very weak southeastern trade. Right? It means El Nino condition will be adversely affecting Indian monsoon. On the other hand, when I talk about La Nina condition, what I will be having? See, increased trade wind. What is this trade wind? They are talking about southeastern trade wind. Increased southeastern trade wind means I will be having a very strong southeastern trade. Right? If I have a very strong southeastern trade, not necessarily that will be yielding the best of the condition. My dear friends, let me tell you, the strong southeastern trade may result in flood-like condition with respect to what? Indian monsoon. Correct? Whereas when I talk about the normal condition, the trade wind will also be what? Normal. So let me tell you, El Nino-like condition, I will be having a weak southeastern trade. And this weak southeastern trade will be resulting in what? Drought-like condition. Will be resulting in what? Drought-like condition. Whereas when I talk about La Nina condition, I will be having a strong southeastern trade. That will be resulting in what? Flood-like condition. Now, when I talk about normal condition, what you call it as what? ENSO neutrality. Very technical. Small differences there between this normal condition and La Nina condition, but still let me tell you, La Nina condition will be resulting in strong southeastern trade. Whereas normal condition or ENSO neutrality will be resulting in what? The average or, right, it will be resulting in, right, the nominal trade wind of the southern hemisphere. Okay. So to conclude, if I just talk about, right, ENSO neutrality, right, in what way it will be affecting Indian monsoon. Overall, if I just give you a picture, right, the southwest monsoon, in general, it should be what? Normal when it comes to what? The precipitation distribution. I repeat, El Nino condition, may result in drought-like condition. La Nina condition may result in flood-like condition, whereas neutral condition may result in what? Normal condition. But if you ask me, is this only the factor which will be affecting Indian monsoon? Answer is no. We do have some phenomena happening in Indian Ocean. We call them as Indian Ocean dipole. Right? Even IOD will be affecting Indian monsoon. We have IOD positive phase, negative phase. Accordingly, it will be affecting it. We have something called as MJO, Madden-Julian oscillation. Madden-Julian oscillation will also be impacting what? Indian monsoon. So there are various factors which will be influencing Indian monsoon. But given the condition that now we are experiencing, the so-called ENSO neutrality, somewhere, overall picture if I want to summarize it, the monsoon generally is expected to be what? Normal.
Veranda IAS, where your dream becomes reality.